to the changing environment. And so without further ado, I invite our first and key speaker for this session, and that is Benga. Why are you up here? Yeah, you're speaking. Use the podium. I invite Mr. Benga Onimo, who is the commercial director at Lafarge Africa. Please take the podium. Yeah. You have just 10.5 minutes to present.
With the media team, please, can you help project me? Thank you very much. Good morning, everyone. I'll be standing on the existing protocol. Again, we from Lafarge Africa PLC, a member of the OSIM group. I know a lot of people know us as Lafarge OSIM, but very recently we changed our name, rebranded. We're now OSIM as a group point of view. We're talking housing. I mean, very interesting conversations we've had in day one. And I think when we look at all of this, the big thing that comes around is that, yes, there's need for housing. Can you go to the next slide, please? We all agree. I mean, the world is changing, population is increasing. There's definitely more need, more demand for housing, and it will continue. You know, that deficit we talk about, we continue to widen. Regardless of what we put in numbers, I think the common point is there is need for more housing, right? And again, if we look at the way we build today, it's also a concern. I mean, it served us, yes, it's taken us to where we are today, but of course, looking at where we're going, we need to move faster. We need to do more. And it's nothing just come easy. So it means we need to find ways of building faster. We need to find ways of building more cost effectively. Yesterday, we talked about financial products, you know, to support this vision. But, I mean, the pocket is not endless. So we definitely need to ensure the methodology of building also can be more efficient, more cost effective, you know, find a way to take out really, you know, waste in the whole process. And I think that's very important. And that's where for us, when we look at the way we build today, you say, there's not been so much innovation. It's been really very traditional, same for a long time. I mean, we all know it's brick and mortar most of the time, you know, and again, it takes its time, the process and all of that. And if we look at it, the cost of materials that we use for all of this, it's a lot. Apart from the cost, there's multiple materials, and which requires a lot of people, labor also. So sometimes, I mean, when we were talking yesterday, I was listening and trying to imagine to say, when you actually look at cost drivers, you know, apart from the land, when you look at cost drivers in putting up affordable building, a lot will be around materials and labor. So really, if we have the right technology that mentioned the number from Shelter Africa in terms of the deficit, I think she was talking about 56 million just among 44 countries in Africa. 56 million, that's massive. You're wondering how long it's going to take us to build. So it means we need to build faster. The current way of building today probably won't help us to get there. And again, it's also very important. I mean, our theme is talking resilience. So sustainability, it's also very important too. The carbon footprint, we want to go greener, climatic, we all talk about climate change and all of that. So how do we ensure also the technology for building also helps in that perspective? These are concerns for us also from a Lafarge point of view, which makes it very important to think around the technology that can address this. So for us, really, we think we need to start, you know, building new generation houses. You know, some of us will say, oh, are you sure of this? But the fact is that there are challenges in the world today. And we need to start building better, more affordable, more eco-friendly. You know, we need to go green and cost efficient. And of course, it needs to also match the timelines. Yeah, the next slide, please. So I'd like to show very quick, no, sorry, the video. Hello, media man, can you go back? Yes, can you click the video, please? So for us today, thank you very much. So our focus today is on the 3D technology for construction. That's really what we want to focus on today. So for us, there's a need for a change on what we do today. And what's 3D printing, really? It's simple. It's simple printing. Basically, you know, sequential layering of materials. You know, you just keep, you saw the machine, keeps going on, laying up the materials till you build. And that's what it is. You know, specifically for housing, it's about building the walls of the building, the walls of the house. That's what the 3D print will do. It builds that, keeps laying up the material, and you build the walls very quickly, both internal, external, and very fast, very fast. Within a few hours, you can actually put the walls of a building. In Malawi, for example, the school was done in 18 hours. A school on a 56 square meter was done in 18 hours. The entire walls were built already. So that's really what it is. It's as simple. It's as simple. And we already in Lafarge are already aligned in this technology. I mean, someone will say, oh, you know, this is digital. Are you guys sure about this? Yes. I can show you. You'll see the next video. Classrooms, children are already in there learning. So it's real, it's live. And for us, when you look at the benefits of this, right? Like I said earlier, we'd agree that material costs is an issue. I mean, you and I know today when you're building, yes, they tell you this is the amount of material with your BOQ and co. But managing the materials, there's a lot of waste, there's a lot of loss, you know, that happens at sites through materials. But with 3D printing, you don't need to be bringing materials to the site. You're just going to load up materials that you need exactly. It's in the machine. So no one is going to, you know, shortchange you. And from what we've seen so far, about 60% savings actually you can make on materials. 60%. Productivity is also, like I mentioned, speed. 18 hours building the walls of a school. Once you put the framework, the walls, then you're ready to go. Flexibility and scalability that this can also give you. You know, your shapes, the size, different things you can do. You can manage it in different ways and create some aesthetics leveraging on this. So it can be customized also to what you want, you know, and that's the beauty of the 3D print. Logistics, when we talk about construction, can also be a challenge and a cost driver. And that's one of the things that this helps. With 3D printing, you can cut off a lot of unnecessary costs. And this is where you make the savings. So you're getting speed, you're making savings, and of course, it's also, we're talking green. Next slide, please. Simple process. Sorry, you move too fast, Mr. Can you go back, please? Go back, please. Go back. Back. Moving too fast. Yes, sorry, that's it. So 70% time from what we've seen that you can gain, 70% savings on time. Okay, next. And for us in Lafarge, next slide. For us in Lafarge, we're not on this alone. So the approach is really, bringing all stakeholders together. We're not working alone on this. Contractors, developers, design offices, printing companies that would make the printers, because you have different sizes, different printers you need for depending on the material you want to use. And of course, with the academic body, research a lot. We actually invest a lot in research. We have a huge R&D office in France that we leverage on, that's been working on this. So again, that's the way we started the process. The next slide. And we've gone through the different stages, for every project that we've tried to test this on. First is looking what's the product, the design, the print technology, and the material you want to use. The next, so this is just telling you that, you could think, oh, 3D, next slide, 3D print, in some place, would you need to use reinforcement? Yes, there can still be some reinforcement. Can you go to the next? I'm trying to move very quickly because I can see I'm being notched already on time. So with respect to the material, the ink that's actually using to print, we have the technology in-house. We're making that also in-house. We are, of course, we are strong with building solutions, cement, dry mortar. So all of these technologies are also what is necessary for this. So we already have that. We're experts in that already. And the different mixed material that you can actually use. So examples of structures that actually we've worked on. Can you go to the next slide quickly? If you can click on that video, go to the next slide. Yes, just click on the video. You see the school I was talking about in Malawi, and with purpose of it actually fantastic. That's the school, sitting on 56 square meter, very quickly done. And for them in Malawi, when they look at the deficit they have in terms of schools, they wanted to focus in that area to close 36,000 schools that backlog they have. And this actually a way to go. So we're actually leading that. If you go to the next slide, please. Yes. And also a 2-bedroom house done already with the family. I think this was actually sponsored by Habitat for Humanity. And again, you can see some designs from Iraq. So we're working across Africa. There's several projects actually that we are on this. And this is just to give you also a feel. Next slide. On some of the big projects doing turbines, you can actually go high. So again, question is around, can we go multiple floors? Yes, we can. But we've seen that in some other countries. In Nigeria, we want to start stage by stage. And I think when we look at the needs we need to address, actually, you actually want to start from ground floor. So this is a footbridge that will be used for the Olympic Games in 2024. And Lafarge already has the right to actually, build this there. So this already work is going on and will be live. And if you look at the next slide, please. So again, this is another bridge, footbridge. Can you click on that video? A footbridge that Lafarge also has worked with other partners, companies to actually bring to life also. And this was in, this is in Venice, in Italy. This was opened just in July the 19th, precisely, that this was actually open.
No glues, no binders. It uses the minimal amount of material for maximum strength. 3D printing opens up a world of possibilities, all the way from complex infrastructure projects to affordable housing. We can reduce up to 70% of materials with no compromise on performance. That is a breakthrough from a sustainability perspective. And that, for me, is building progress.
Next slide. So for us, it's impressive. We're quite happy. This is just showing you different into the 3D thing. So we create in various universities. Can you go to the next slide? And for Nigeria, our approach is we're building a 2-bed project, hospital project as a CSR, somewhere in Shagam with 3D. And this once it lands, next slide. So in terms of technology, in terms of resource, we have it. And we're working with a company, a sister company of Lafarge, based in Kenya, that will be using across to run this in the entire Africa. Thank you very much. Sorry, Mr. Chairman. Thanks. I know the time was not enough, but I think we can talk more during the time.
Thank you, Benga. I'm not going to take time in commenting on what he said. I'll leave time at the end for that. The next speaker is Professor Brando Okolo. He's a founding director, Germany-based Steinberg's Institute for Materials Application and 3D Printing. Professor, you have 10 minutes.
Okay, thank you very much. Yeah, thank you very much for the opportunity to talk on this forum on a very interesting topic, 3D printing technologies. It's a technology that's been in the works for the past 35 years. And we've seen it grow from being a rapid prototyping tool to now being a construction tool. And beyond the current topic of buildings, you can also use 3D printing technologies to essentially build all kinds of machine tools, consumer products, and interface with all kinds of industries. Okay. Next slide, please. So for my presentation today, I'll first of all try and give an overview of what 3D printing is and why you should use this technology within the construction industry. I'll talk about 3D construction printing today and in the future, and I'll give a few final remarks. Next slide, please. So what is 3D printing? Luckily, the speaker that spoke before me, he's already given an insight into what this technology is all about. So imagine you have an extrusion machine, a machine that allows you put down material in a layer by layer fashion until a 3-dimensional structure is built up. That's essentially what the machine is all about. But the first thing, of course, is that you need to come up with the product you want to design, or what you want to fabricate, whether it's a house, an engineering part, whatever it is. The starting point for that process is in the design. So you need to be able to use design tools to produce what you want to fabricate. Next slide, please. So I'll quickly give an overview of what 3D printing, or how the process of 3D printing goes. Can you go back, please, if you don't mind? Yeah, exactly. So imagine you have the sculpture. There are two ways you can actually produce this sculpture. First is by taking a block of, can you click on the, yeah. First is by taking a block of stone and chiseling out everything on that stone that doesn't look like a sculpture. Next slide, please. The second is by having a free surface on which you start putting materials together until a 3-dimensional structure is built. So in both cases, in the field of manufacturing, the first example is called subtractive manufacturing, where you have a big block, you chisel out everything or chisel out material, and then you have your final product. The second is called additive manufacturing. I'll come to that, why 3D printing is being scaled up to additive manufacturing. So additive manufacturing involves putting materials together in whatever form, either in the form of pottery work, in the form of casting, and of course, also in the form of 3D printing. So the word 3D printing is today used generic to describe the technology, but strictly speaking, this is called additive manufacturing. So what you find in engineering textbooks, what you find in textbooks that are used in The academic word is additive manufacturing. Next slide, please. And so today, essentially all existing engineering material or technical materials can be 3D printed or additive manufactured. So you can 3D print paper, glasses, ceramics, polymers of all forms, metals, concrete as we have it today, and all kinds of other composite materials. Those today can be 3D printing, including concrete as we know it. Next slide, please. So what does a 3D printing workflow look like? As I already mentioned, you start off with a design, and that design can be generated either using your computer-aided design tool, or you could use a 3D scanner to generate that design. Now, the data you generate from that is then prepared for the printing process. So the preparation is simply a transformation of your data format from one form to a machine-readable format. Next slide, please. And the machine-readable format then allows you, that data allows you print or lay down materials in a layer-by-layer fashion until your three-dimensional structure is formed. And so you see a system that allows you build structure, build it fast. If you could scale beyond that point of just building one structure and building fast, you can go into a point where you're building several and building fast. So imagine this industry, this very conservative construction industry, becoming a mass production line. This is what we're looking at. We're looking at a case where you can actually take this technology, not just build one, but build several in a very intelligent way. Next slide, please. And so the key components that makes the use of this technology advantageous are speed. Speed is important. Speed allows you as an investor, put your money down and as quickly as possible, reap that revenue or reap the return on investment as quickly as possible. The less use of materials, because only the amount of material that is precisely needed is what this machine will lay down. And of course, less labor. I've had discussions with people here in Africa where we've looked at the labor significance of using this technology. So labor is very cheap in Africa, so it doesn't matter. But we have other aspects of labor that allows this technology come into play. The construction industry is a very muscle industry. It's an industry where the labor we need on site is muscle labor. So you get to a certain age where you're no longer required in the construction industry, even though you come with a lot of experience. So what this technology allows you to do is to transit from a position where you use a lot of muscle to where you use brain power to build. It also allows the female folk to come into the construction industry and perform. And of course, the ability to build relatively complex architectural works. This technology allows you to do that. It's eco-friendly, and of course, reduction in injuries that we find in the construction industry. In the construction industry, there's a lot of injuries, human injuries. You can significantly cut this down by bringing this technology on site. The good thing about it is that the amount of people you need on the construction site can significantly reduce. With this technology, you only need 3 people on your construction site. You need your CAD engineer who drives the machine. You need your materials engineer who ensures that the pumps that pump material from a silo or a reservoir to the print head is moving unobstructed, and you need a structural engineer to make sure that all the parts or all the materials that have been laid down as you build your building, that those materials conform to all kinds of engineering requirements. And so from a comparative point of view, where your savings mainly come from, when you look at the entire value chain within your construction field, land, permits, materials used in building of the superstructure, the fittings, the finishing, when you look at all these cost components and you insert this technology within your costing, the key areas where you see significant reductions are in material and in labor. And those reductions are significant. They really are. To the point where you can cut down, when you compare your conventional building, you can cut down by up to 50% in cost. That is a lot. And this is what this technology offers. Next slide, please. Now, when you look at the industry globally, as I said, it's still the technology is young, and so its use within the construction industry is also quite young. but we already have a space that is populated by all kinds of groups. Groups working on the machine manufacturing, groups working on the materials manufacturing like Lafarge, groups working on the software that is used in driving this technology on the construction site. So I've put up these companies to give you a sense of where they are, who they are, and which fields they are working on. There's still a lot of work to be done, and I think we'll get there at some point. Next slide, please. So globally, 3D printed houses exist essentially on all continents as we speak today. In Denmark, the company which Lafarge partners with, Cobod, they are the machine builders. We also have a partnership with them. They'll build the first 3D printed house in Europe. We have houses now printed in Italy using earth, mud. We have houses in Russia, in Germany, of course. We have the first family-built 3D printed house existing in Germany, in France, in the USA. Next slide, please. In the USA, in Belgium, in India. Next slide, please. In China, in the UAE. Next slide, please. In Saudi Arabia and in Malawi, which is the first encounter this technology has had in the construction industry within our continent. The next slide, please. Next slide, please. Good. So what does this technology hold for us beyond today and beyond? Beyond today, what we can do with it is that the transformation we expect to find also in the construction industry could start. We already have software tools, the so-called BIM, the Building Information Management tool used in the construction industry that allows you have a complete overview of from the idea to the point where you actually have a finished product. You check on your cost, the amount of material used, the timing, the scheduling. This tool, the insertion of 3D printing technology within this tool will revolutionize that sector. It would allow you approach a client, say to the client, this is what I want to build. The client says to you, this is what I want to build. You interface with the client on a computer surface. The client is able to scale the land which they've bought to the architectural work. It allows the client to have all kinds of optical understanding of the architectural work they want to have built up, the simulation work, the time it would actually take to be able to build that structure, the amount of materials that are needed, the renderings, gives the client a completely new experience about the project work or the project work they're trying to build up with you. It allows the client understand what's happening on site without being physically on site. And of course, it allows the client have a first-hand understanding of what it will be like to have their own house. So this is where we are. We're at the point where the data that is generated from the architectural studio to the data generated on the construction site gives the client and that gives our economy a completely new experience. We've heard, for my conclusion, next slide, please. Next slide, please. Good. So we've heard that the affordable housing gap is widening and that bridging that gap is difficult. I don't want to debate over the numbers. Whatever the numbers are, we have a problem. We have an affordable housing gap, and that has to be bridged somehow. Using conventional manufacturing methods, we cannot easily bridge it. So we definitely need a technology that will come and speed up that process of bridging this up. In terms of cost, this technology would allow not just those in the middle income class, but also those in the low income class to be able to own their own building as well. So my appeal to you as a community deeply involved in the construction sector, bring this technology not just into the Nigerian construction world, but look at Africa. You are industrial heavyweights, go beyond Nigeria, adopt this technology and see yourselves do something unique for our continent. Thank you very much.
Thank you, Professor. We'll leave time for questions at the end of it.
Okay, thank you.
Take your seat. Thank you. Our next speaker is sitting right to my left, Mr. Babajide Odusholu. Yeah, it's you next. He's MD, CEO of Octo5 Real Estate.
Good morning, everybody. All protocols duly observed. Unlike the two gentlemen before me, I'm not selling 3D technology. I think I'm more coming from the user's perspective. And the first thing I just want to observe is this: construction technology is of critical importance. We're all avoiding the big question of what is our actual demand gap. But I don't care whether you call it 17 million, or as the Honorable Minister from Ghana said, where they have 2 million, or you call it 2 million. It doesn't matter what you call it. The fact is we have a crisis. In Nigeria today, and my Oga Benchima is here, I doubt there's anybody who's building up to 100,000 houses a year, government included. The maximum production per year in Nigeria is not up to 100,000 homes. And whether you believe it or not, the real demand will keep growing because 50% of our